You have transistor have two main categories, was the BJT and the other one is field effect transistors. MOSFET is a type of field effect transistor. Transistor have three terminals, and then you can control it by changing the voltage or by the application of or current to the input terminal. Okay, the BJT and MOSFET, the physics is very different. Okay, both of them are transistors. They can work as a switch. They can become amplifier. Both similar in terms of the application, but how it works, the physics is very different. Okay, so we'll be learning inshallah in this class. So you can use transistors in many things, in amplifiers, linear regulated power supplies, switches, logic gates, RAM, microprocessor, everything. Nowadays use transistors. Okay. Okay, apa benda ni? Okay, bipolar because both carrier, hole and electron play an important role in the operation. FET are unipolar, meaning only either electron or hole that determines the current inside it. This is the, what do you call it, the symbol of a, nampak ke ni? Of a BJT. Right, you have two types, NPN and PNP, and there are three terminals: collector, base, and emitter. Okay, we learned this in your first year. Ini baru introduction lah. So modern transistor, you can see this is the single. They call it, sometimes they call it discrete device, one by one. But you can actually make it smaller. The packaging is actually big. The transistor inside is very small. Okay lah. So BJT fabrication. Okay. The fabrication of BJT, you need to see how a BJT looks like. It looks like this, basically, in terms of layering. Although you see here, it looks like this. N, if you draw, this is your N-type, P-type, N-type. P-type material, N-type material, P-type of semiconductor. Then you put three in a row like that, you get a BJT. However, in real life, when they try to make the BJT, it's not like that. In real life, at the factory, when you're real time to make, first they make everything here, they make it N. Then they dope it this side, the whole P. And then the small side here, they dope it N. That's how they do it. Okay. So that's why I say BJTs are usually constructed vertically. It will control the depth of the emitters, the doping sets. Sets the base width. A base width is this one. So it's difficult to, one of the difficulty is to control the depth. When they dope it P-type here, sometimes they want to dope it only this thick. But due to the way you grow, sometimes it become bigger. So you need to have a good control of the depth of the emitters doping sets, doping of the devices. This is how the mode. You learn this in your first year. There are like three, four here because inverter is the inverse of the active. So you have the saturation mode, you have the forward active mode, and you have the cut off. Okay. So saturation mode is where you forward bias both junction. Remember this is NPN. NPN is easier. You have N, P, and N, and it's actually just two diode back to back. Okay, two diode back to back because this is a PN junction. This is another PN junction. So you and this junction, for saturation you forward bias this both junction. In forward active mode, you forward bias the base to emitter junction only, and you reverse bias the base to collector junction. In the cutoff, where you don't want current to flow at all, you just reverse bias both. And so basically what happens is you have three terminal. You have the emitter, you have the base, you have the collector. And actually, it's just two PN junction. So it's very simple. That's why after PN junction, we are learning BJT because it's very similar. So here P and N. So you P like that, N like that. So like that. Here is P, here is N. So like that. So basically, it's just a diode back to back, right? So that's why saturation mode, you forward bias both junction. So here you for junction, this we call it base to emitter junction or base to emitter diode, or here you call it base to collector junction. So in saturation mode, you forward bias both junction. In forward active mode, you forward bias the base to emitter junction, but you reverse bias the base to collector junction. It's just a diode. So now let's see what happens, okay? Now we talk about how the carrier move, then later on baru, then we'll talk about the energy Venn diagram.